All right, welcome folks to one of the first sessions of Heat Pump Water Heater Day / Heat Pump Water Heater Week. This is the session focused on connectivity in water heating. So I have a couple great panelists with us today. I'm just going to give folks about a minute here and then I'll get into it. We're just hitting 10 o'clock sharp on the hour. And so who we have with us today, Karen Fenaughty from Florida Solar Energy Center. Karen's been doing some great research on heat pump water heaters for the last several years. She and her team have put out a couple of excellent research papers on load shifting, both in labs and in the field in Florida. So super happy to have her with us today. And then Tristan and Daniel from SkyCentrics are both here. Tristan's the founder of SkyCentrics. It's a great company focused both on making universal communications modules, skyboxes, and other kind of hardware and software designed to enable load shifting from a variety of different sources, including water heaters. And then they also just have a bunch of great data tracking as well. And Tristan will go more into that. And then I'm Gabriel. I'm a project manager at NBI. I've probably seen many of you before on various webinars that we've hosted. With that, I'll get into it. Happy to have you all with us today and happy Heat Pump Water Heater Day. The sponsor of this webinar is the San Diego Learn program. So that's a San Diego-based workforce education and training program. They've partnered with us for a bunch of great webinars, and you can visit their website, www.sandiegololearn.com, to see a bunch more of their recorded content. So a lot of great educational resources from SD Learn. Just a couple quick housekeeping things and some exciting giveaways here. So there are a ton of events happening this week, notably today, and then also mainly on Thursday. So this is kind of our warm-up day, a bunch of great events, and then Thursday is like the main heat pump water heater day, where we have events starting at 8 a.m. and going all the way till around 3 or 4 p.m. Pacific. So definitely be sure to sign up for that on HPWH's page. So here's the link for the full program. You can scan it with your phone, or Shannon will also put it in the chat. Shannon's kind of running the behind the scenes here today. So definitely, be sure to check that out. We have a great keynote with Jigger Shaw, who I'm sure a lot of you have heard of. He was a host on the Energy Gang, among other podcasts, for a while. Really excellent speaker. And then we have a stacked lineup for the rest of the day, all different sorts of heat pump water heater topics, from commercial heat pump water heaters to energy storage and equity, a bunch of other things. And we definitely encourage you all to make posts, kind of spread the word on this great event. We have participants from, at least a dozen different organizations. So definitely want to spread the news, spread the webinars, all of that. So you can use this to quickly make a social post. And if you do, and you use the tags hashtag Heat Pump Water Heater Day and hashtag GoGo Heat Pump Water Heater with the abbreviations, then you'll be entered to win a free heat pump water heater giveaway from either Bosch or Ariston. So if you want a free heat pump water heater, definitely make a post there. And then we also have a fun agent badges partner toolkit. So this is an example of my colleague Joe here in his iconic heat pump water heater costume. So if you want to click this link, you can make a little badge for yourself, say what your mission and what your agent name is. It's kind of a fun way to make a post that you can also use these same tags from the previous slide. So with that, I'm going to stop sharing and I'm going to hand it over to Tristan from SkyCentrics.
All right. I really appreciate all of the influencer techniques there. Those are very cool. Thank God for young people getting involved in heat pump water heaters. Okay, so normally I'm sharing my screen here, and then are we seeing the deck?
You are indeed. It looks perfect.
All right, awesome. So I can see there's a number of people on here that I've seen before. Welcome. even though we're talking about flexible load of residential water heaters, we really want to focus on commercial because there's been a lot done with residential in the past, and commercial is really exciting, right? Larger loads, commercial multifamily especially has the same classic domestic hot water profile that we love. And so it's kind of exciting to be able to get to those loads. One owner may have a lot of multifamily apartments, so we'll be focusing on that. I'm going to skip through some slides. This is just a little glossary. It looks like a lot of people here know most of these things, but if you download the deck at a later time, this is just a little bit of a glossary. This is worth just spending a little time on. Most people here know about the Washington and Oregon law that kind of broke open the EcoPort socket for machines, right? So this white rectangular socket is on water heaters now. On every new water heater sold in Washington and Oregon since January 1, 2023. And that means there's about 100,000 a year. 250,000 have already been sold into Washington and Oregon. So that kind of really broke open this open standard for water heater connectivity. California has Title 24 JA13. It's a little more complicated, and it does require the EcoPort socket, but not on every water heater sold in California. And then Colorado, the city of Denver, has started something. We have it actually in detail on this slide that if you are putting in water heating, I believe it's multifamily. It doesn't say multifamily here, so it says electric storage water heaters must be CTA 2045. Daniel, do you know if that was the whole any water heater in Denver or just sort of multifamily, or you're not sure?
Unsure.
Okay, great. So why, is the EcoPort CTA 2045 open socket so worthwhile? Couple of quick points, right? Vendor neutrality avoids walled garden and vendor lock-in. So the most important thing is that it's for stranded assets, for all of you who are utilities, it's going to be the least expensive way that if your vendor ever goes out of business with that white module that plugs into the water heater, that you can just mail everybody a new module. We've seen even big companies like Google end of life certain products that just become bricks in the Internet of Things world. So I think that's one of the big reasons that the EcoPort socket has value. We call it sort of competitive vendor access. And then also at the bottom, you see better optional connectivity paths, right? Most OEMs at best are going to put maybe Wi-Fi inside it on the residential side. On commercial, it gets a little more complicated, but having that socket, kind of a USB port for machines, allows utilities to say, hey, I'd prefer cellular, for example, which has shown itself to be a little bit more long-term connectivity guaranteed than Wi-Fi. Because people change their passwords, change their router, change their provider, etc. Now, I worked on this with Jeff Wicks a few years ago. This was a matrix to kind of show all of the options that you could have. It's very small writing. You can reach out to us if you want the details of this matrix. We can ship it to you. We were hoping to have it downloadable but it wasn't available. So the important thing is the far left column in green is cellular EcoPort. And so what are the issues that are in red? I'm just going to highlight those quickly, right? If you have OpenADR on the machine, which is really rare, OpenADR in the cloud is usually what happens, then you can't easily do firmware updates on the machine because the OpenADR is talking to the utility directly, and the utility can't send firmware updates from there. And sometimes firmware updates are needed. OpenADR in the cloud, then the OEM, like I know some water heater manufacturers have an OpenADR cloud, and then they can still send firmware updates, but it's only by however they chose to communicate between their water heater and their cloud. And then if you have OpenADR in the cloud, it becomes a stranded asset. So the nice thing about a cellular EcoPort module, it's always there, and it could actually be redirected to a new vendor if the original vendor goes out of business. You don't even have to mail a new module. All right. So this is what SkyCentrics is known for. It's just a quick review. People who haven't seen the module, right? There's the module in white on the left. It plugs into the EcoPort socket in the middle. And we are providing that black skybox in the middle to a number of vendors so that their commercial central heat pump systems and even their HVAC VRF systems can become OpenADR and EcoPort compliant.
I think you might have frozen up there, Tristan. Daniel, are you able to hear Tristan, or is he frozen up on your end too?
Looks like he's frozen up on my end. Let's see if I'm able to take control of the presentation real quick. I may be able to. Okay. All right. Can everyone see my screen?
Looks great.
Alrighty. So I will be taking over in the interim while Tristan is taking over some technical difficulties. So I'm not sure where everyone else lost him. But essentially, the Skybox provides that EcoPort to Modbus BACnet adapter and helps provide certification for a lot of other OEMs. And then our solution for full building orchestration is the Super Skybox. So that has a little bit more processing power, can connect to multiple machines at once. It's DIN rail mountable. It's IBB, the interoperable building box compliant, and it can connect via Ethernet, cellular, or LoRa. So moving on, essentially the cloud management platform that SkyCentrics brings all this data to is the Dream platform, and it works to integrate building specific data, generic building data, which is essentially data sheets. That's that data that doesn't change, that basically occurs at the time of install. You have all this building data that's not going to change. It has live building data, so that's going to be your day-to-day, your power metrics, your temperature sensors, basically everything telling you what's going on in the building at a given day. And then you've got your live internet data. So that's what's going on outside the building. So that could be weather, that could be grid signals, that could be carbon data. So it basically aggregates that all into one using basically machine learning algorithms and provides that all on the Dream web platform that the building manager, engineer, owner, anyone else can access and see all in one place. So beyond that, SkyCentrics is making a big push into the multifamily, where we believe that that Ethernet connectivity to one cellular endpoint for multifamily is a huge sweet spot for getting large load connectivity all at once. You can have dozens of water heaters on one cellular endpoint. We find this ideal for retrofit or new construction. Basically, you're seeing very low cost of connectivity. There's no reliance on Wi-Fi, so no drop-off. And the way we do it is we provide up to 25 Ethernet UCMs to one Skybox, which can go up to SkyCentrics Cloud, or we can have up to 150 UCMs to the Super Skybox, which goes up to the SkyCentrics Cloud. It looks like we may have Tristan back. Would you like
I'm
to take
so sorry. First time my computer's ever rebooted in the middle of a presentation, so I apologize. So Daniel, go to the next slide. We'll just keep going.
Yep.
All right. So these are the people that their central system water heatings are now EcoPort compliant and even OpenADR compliant. Mitsubishi has presented on a number of things about their QAHV central system water heating, which is exciting. You may have heard of the Bayview apartment buildings, but they're also now their VRF HVAC is also, all of their VRF HVAC systems are now going to be able to be grid enabled. So that's very exciting. Next slide. Yep, go, keep going. Keep going. All right. So with the NIA end use study, we were really able to break up groups into cohorts of heavy users, light users, and deep user, excuse me, heavy, light, and lighter. So the green shows when they're not being close to a cold water event. And that little spike into the red above shows that they're being close to the cold water event.
So that's really exciting that EcoPort socket water heaters allow us to see the storage capacity, and which is essentially how cold the tank is, or not hot. Next slide, please. So we determined in a, let's just say 100 water heaters that about 76% never get close to being a cold water event during their normal use. There's heavy users that get close a little bit sometimes, and then there's very heavy users that, you know, we have to be very careful with. So we already split those open to groups. Next. All right. So right now you can see the whole cohort being done. Sorry, next slide. But I think I got the idea across, and we're going to be a little bit late. So one of the things that we can do besides sorting by hot water usage is time of day use. Geography, there's actually geolocation through cellular, and potentially you can put a chip right on it, obviously, that gets you 3 feet accuracy or 3 meters, but the cellular towers actually get you within a mile, so at least you know typically what territory it's in. Next slide, please. All right, so one of the things that we did with the end-use load flex is something called smart feathering. So smart feathering means that there's usually a large snapback because you've been withholding the water heaters from heating during a shed for 4 or 5 hours. So all of a sudden they all come on at exactly the same time. Not a big deal for a couple hundred water heaters, but you can imagine for 1,000,000 water heaters, that would be a big snapback on the grid. Next slide. So we basically reduce that and flatten it out. How do we do that? Next slide. We basically group each device in the fleet by capacity of how far away they are from being fully heated. And we take basically the coldest ones first, and we heat those up first. We break the group. You can choose actually how many groups you make and how many minutes each group has, but the bottom line is it's smart feathering so that you don't have that snapback. Next slide, please. We also have something called TOU price shape. So if you've gone to our website, you've seen this. This is August, weekdays in August of the California grid. And it shows how that lake that we're trying to fill with the peak over on the right, it changes quite a bit. And then where do you start the ramp? When are you sort of supposed to do things? So that's every day shifting, and it's our pitch for real-time prices as opposed to time of use. Because time of use, you can only change it every 6 months, let's say, at most 2 or 3 times a year. Next slide, please. So what we can do is look at the real-time price shapes that are typically published 24 hours ahead. On the far left, you can see KISO and ERCOT, etc. This is a price shape, and then you can see the load ups in purple at the top bar and the pink sheds when it's high price. And this is really exciting because you're doing prices to devices and doing what we say is we grab the price shape and we create an action shape based on it. Next. Same thing here, but single peak versus dual peak. So you can see that we focus on loading up when it's inexpensive and shedding when it's expensive. Next slide. All right, so these are some features, not a lot of detail here, but we noticed that some OEMs have different representations of their capacities, so sometimes we have to adjust those so that they make more sense. We're also doing load shift prediction. This estimates in terms of your instant kilowatt reduction and your total kilowatt hour reduction through the event. So people can actually use our platform to predict the behaviors of the events, potentially bidding into markets. And then I'm going to go to the next slide. Next slide. All right, so this is the beef of the matter, the case studies. So what we're excited about with the NEA end-use load flex study is right at the bottom of this slide, you can see that we had 27% electric resistance, which are not heat pump water heaters, and 73% were hybrid or heat pump. Although actually now I'm not sure because I see the word hybrid, so does that mean the others were in electric resistance only mode even though they were heat pump? But no matter what, what's nice is that there was in Washington and Oregon, every new electric water heater has to have an EcoPort socket. So we're finally getting data on how an electric resistance only tank can benefit the grid by flexing. Next slide. So what we did is we provided the homeowner materials. You can see those on the left of how to install this. The idea was that they install it. We had a mobile app, Android and iPhone, so that they could take a picture of their meter because multiple utilities were involved. The most important thing we did here is we grabbed a picture of the nameplate of the water heater. So that was awesome because we really got to see which model of the water heater was being used, and that really helped us out. Next slide. So we learned a whole bunch of things here. Most people installed it on their own. That was great. The long-term connectivity of cellular worked really well. And then there was one utility that sort of shipped modules with the water heater, but we have no visibility on whether the water heater was even installed. Hey, they got a free water heater. Maybe it's still sitting in their garage. So we're not sure on that. Next slide. I talked about the OEM variants, so we've worked on the storage capacity numbers to normalize them. I talked about grouping by household, and I'm going to go to the next slide. Thanks. So here's, again, I really want to focus on commercial, so that was residential. So this is PAE Engineering headquarters. It's called the Living Building. 4,000 people tour this building every year. And it's one of the most advanced examples of regenerative design. And yet, after they built this building and they had all of these cool things like solar panels you can see on the roof and a microgrid controller and a battery energy storage system and a building management system, and what was missing was the data. Next slide. So believe it or not, there was what they wanted to do, their biggest use case was take that solar and use as much of it internally as possible. So they wanted to turn on these water heaters, and they had asked that everything be connectable. And these water heaters had zero way, no Modbus, no BACnet, no EcoPort sockets. So the manufacturer's actually sending us new boards that have the EcoPort sockets because thanks to AHRI, commercial building specifications like 1380 and 1390 are coming out and encouraging water heater manufacturers to put CTA 2045 sockets on commercial equipment. Mitsubishi, as I said, has already done it, so we're excited to be able to do that. Next slide, please. Here's a situation where Water Drop Systems is doing this great skidded solution for commercial buildings. But again, when they were leaving the site, they were completely blind once we left the project site, which is often the case. And these systems, commercial systems with swing tanks, they're more complicated. And if the heat pumps go a little bit out of whack, the swing tank takes over. It's providing hot water, but it's using massive more electricity. You're not getting that heat pump miracle benefit of the coefficient of performance at 400% or 4 rather than down in the electric resistance. So it's really important for these heat pump systems to be monitored in real time so that they can kept alive. Ecotope, as you know, has EcoDash, and we're working with them to try and help all of that analytics come in to cellular connectivity. Next slide, please. So here is an example of what they're providing through the Skybox, right? You're getting tank temperature, load shift controls, price shapes, and our dream platform is there, demand response energy and asset management. And believe it or not, Water Drop is working with a Canadian utility to do a whole bunch of load shifting on these big water heaters. So commercial load shifting is going to be here, especially through Water Drop. It's already been happening with the QAHV. It's happening with a few of other manufacturing partners, but this is going to be exciting to do a whole bunch of them in Canada. Next slide, please. All right, and finally, the Cal Flex Hub did some testing on these multifamily sites in San Francisco that also had QAHVs. Next slide. So what we noticed here is that there was no access to whole building metering, and all of the energy shifting that they were doing was based only on time of use. So Daniel, can you speak a little to this slide?
Sure. Yeah. So essentially, the two limitations that we saw were that they were using the CalFlex Hub estimated dynamic pricing for all their pricing estimates, their savings estimates, etc. But we saw that that didn't actually reflect what the building owner was paying, and they were seeing actually greater electric bills because their electricity tariff was different than that CalFlex Hub assumed pricing. So essentially, once those studies were finished, they were left without a schedule. So SkyCentrics is essentially taking up the mantle of this and working with the building owner to optimize for their schedule rather than the CalFlex Hub assumed pricing schedule.
Great. Next slide, and then we only have 1 minute, Daniel, so I'm going to ask you to go pretty quickly. So here's a heat map. Monthly heat maps are really cool. Next slide. This is another way of looking at the data. Next slide. So basically, you can see that we shift a lot of that peak period into the red of the blue squares. Next slide. This is just exciting of what's coming because buildings are being pulled in every direction. Next slide. So for commercial buildings, there's really exciting stuff going on with the Linux Foundation, the Coalition for Smarter Buildings, and all these open standards that are being brought to commercial buildings so that AI can get involved to manage all these complexities automatically. Next slide. And we're going to go really quickly through some benefits for the residential and people inside the building. So go ahead, Daniel. It turns out that we can do whole home leak detection because of the slope of the cooling. Next slide. So here you can see there was no leak versus a fast leak and a slow leak. So just from that midnight to 4 a.m. when there shouldn't be any behavior and just cooling, we can see the leak speed or the cooling speed. Next slide. And then we even detected compressor failure. So that's sort of fault detection on these systems because they just behave very differently. And I'm going to stop there to give my next colleague more time. Thanks.
Thanks a ton, y'all. That was great. And so cool to see the multifamily focus too, because as Tristan and Daniel mentioned, right, it's a big power output and input from multifamily systems. And then demand charges can be 30 to 70% of a building's cost. So being able to shift those away is great for saving money and, of course, emissions too. So thanks again, y'all. And there's some Q&A, but we'll hit those after Karen goes. So Karen, if you want to share your screen.
Hello. All right. Is that working?
It is indeed. Looks great.
All right. So thank you all very much. I am with the University of Central Florida Solar Energy Center, or FSEC for short. And we did a smart water heater project. This was residential. We conducted laboratory and field experiments in the high impact region of Florida to demonstrate the viability of grid connected heat pump water heaters compared to electric resistance water heaters. This was a collaboration between us and the Pacific Northwest National Lab, and this was funded by the U.S. Department of Energy. And I want to acknowledge all the researchers that were involved in this work that I'll be presenting. We conducted this work from 2019 to 2022 in Central Florida using the modular communications interface with CTA 2045. And I'll share results from both the field and the lab component of the project. Our lab involved 5 tanks, 3 different manufacturers, 4 heat pump water heaters, including one that was a prototype that allowed the CTA 2045B protocols to be sent, and I'll tell you more about that later. And there was 1 electric resistance tank in there in our lab. And we had 51 single-family homes with heat pump water heaters enrolled in the field study. And for both of these, we compared a variety of communication strategies. Our high-level finding is that load control of water heaters does work to shed load. And scaling up, we estimate that energy reductions would be possibly 4.9 gigawatt hours for morning peak and 5.4 gigawatt hours for evening peak, that potential is there to be achieved in Florida. And this can be done so that homeowners will likely never notice in terms of comfort or energy cost. And the most effective strategies are morning load up, those with a longer load up period beyond 1 hour, and those that used the higher temperature per load up period. In 2018, grid-connected functionality and advanced control algorithms were beginning to be installed in water heaters. And as Tristan's just told us, it's getting exciting with more and more of that working its way into the market as states make some requirements. And so this allows the utilities to shift demand. They can request water heaters to load up thermal energy storage during periods of high renewable energy generation, like solar peak, and curtail operation during the for load reduction. PNNL approached us to partner with them on this study, recognizing that we have a high saturation of water heaters in the Southeast and especially in Florida with 88%. And these are primarily electric resistance tanks. This is seen as a unique opportunity for heat pump water heater penetration because it offers significant energy savings and demand reduction potential. However, a lot of the large utilities in Florida don't offer heat pump water heater incentives to their customers. On the other hand, many of these large utilities do have demand response and load management programs, which means that the utilities may find value in promoting grid-connected heat pump water heaters capable of load shifting. Test location is very important, so I want to take a minute and talk about our climate here in Florida. We have very moderate inlet water temperatures. In a separate evaluation, we found that the hot water labs draw, this is a lab on campus in Cocoa, Florida, and that the inlet water is purple, identified on this plot, and it tracked really closely to temperatures at 2 feet deep, which is plotted in green. Inlet water temperatures range from a low in the wintertime from the low to mid 60s, and then summertime from the low to mid 80s. The CTA 2845 protocol messages were sent in this method for this work that we had done. We researchers sent messages as a utility might, and these were sent through FM broadcast signals to the connected portal that was attached to the water heater, and then the data were sent back through the portal via Wi-Fi. For our work, we used these messages. This included load up, which is to tell the unit to operate now and raise the temperature of the water to set point. Advanced load up, allowing the tank to come to a higher temperature to provide greater shift capability. And this is only available for the CTA 2045B capable units. Shed load, to tell the tank to avoid operation if it can, to use the stored tank energy to a point. And critical peak, which is a more aggressive avoidance of operation. And then we would cap it off with an end shed to get the tank back to normal operation. We conducted over 200 tests, and they included a variety of morning and evening load up and curtailment lengths. The longer load ups were intended to fully heat the water in the tank, and the curtailment hours reflected the times when system-wide electric demand reductions were of highest value. Here I just want to show you the test structure nomenclature that we used to familiarize you with what you'll see on the coming slides. In my example here, this is a 1 hour load up, a 3 hour shed, curtailment, but a critical peak curtailment. That's what the C is for. And then in the afternoon, we had a 2 hour load up and a 4 hour S for shed curtailment. Each test structure was sent for a period of 1 or 2 weeks. And then in between, we would also collect 1 or 2 weeks of baseline periodically, in which we'd send no communications. So we would have that throughout the year. The lab tests were conducted in FSEC's hot water system laboratory. And this table provides the communications type, the tank capacity, the EUF of the 5 units that we tested. We applied different CTA 2045 control screens under 3 different water draw profiles. And these draw profiles were established by PNNL and NEA. One was a 47 gallon per day, which was meant to mimic a small household and or summertime draw, a 57 gallon per day for a medium household or shoulder season, and then a 69 gallon per day draw designed for a larger household or for colder weather. All of the tested systems were simultaneously subjected to the same water draws, and we monitored electrical power, the tank's inlet and outlet water temperatures, as well as room temperature and outdoor temperature. Here we have demand for a 50-gallon heat pump water heater under the 47-gallon per day draw with a 2-hour load up, 3-hour critical peak, 2-hour afternoon load up with a 4-hour critical peak curtailment test for days where the average temperature was over 65 degrees. The red dotted line is the baseline. The purple is the demand during the testing, and the medium blue spikes are the water draws. And then I've also completely shaded the load up in the morning and load up and shed in the morning and the afternoon. Daily energy use during load shifting is up slightly in this example. It was 1.8 in baseline to 2.2 kilowatt hours, although a time of use rate structure might help obscure this to a customer and they may not see any cost difference at all. Morning and evening peak demand were completely curtailed, as you can see, down from 0.2 kilowatts, and it's completely flat on both of these, morning and afternoon. These are results from the same unit under winter-like conditions with days averaging under 65 degrees, and this is using the 69-gallon per day water draw. Energy use during the load shift test was actually reduced a bit in this example, where electric resistance was sometimes used during the baseline and on the edge of the peak period even. Average daily energy use went from 3.1 to 2.8 kilowatt hours in this case. It does beg the question, was comfort jeopardized to get through the morning peak? And we did take the temperatures, as I said. The minimum outlet temperature measured during the baseline for this baseline for this specific bin was 117 degrees Fahrenheit. And it was 115. The minimum was 115 during the curtailment. So the tank temperature was allowed to drop a bit, but it didn't drop by very much. This plot is an example of CTA 2045B unit's advanced load up capability. This unit we tested was a prototype, and it was able to receive this advanced load up message, heating water above the set point. In this plot, we have a 3-hour afternoon advanced load up from 1 to 4 p.m. We see that after about 90 minutes of advanced load up, the tank temperature in blue reached 145 degrees, and this was the temperature that we allowed for testing. The set point was for delivery was a temperature of 125, and that is in orange, and that was achieved via the thermostatic mixing valve. Here we see the same cool days plot as before, but I've added in the average demand of the CTA 2045B prototype unit in green. One caveat here is that the load up instruction for the prototype unit was only 1 hour versus 2 hours for the A unit. And still, with only 1 hour load up, the prototype with storing higher temperatures completely curtailed the use during the peak periods, even on colder days and even with the higher draw profile. Here's another example of the CTA 2045B results in comparison to a 50-gallon and an 80-gallon CTA 2045A unit. This is under a 1-hour load up, 3-hour shed, 3-hour load up, 4-hour shed test with a 57-gallon profile. Again, demonstrating the superior ability of the CTA 2045B unit to completely curtail use during the peak windows. These examples are indicative of what we saw. We saw that advanced load up does a really good job at curtailing. Here's a summary of some of the lab test results. There's a blizzard of numbers here, but what I want to highlight is what I've identified in red. Each set of 3 columns are results for a particular unit. And the red shows the morning and the afternoon curtailments. These are all shed curtailments and all during warmer weather. All units showed a great ability to curtail peak demand during the warm weather. The one exception is that very bottom test, which was a 69-gallon drop profile with a 0-hour morning load up. So not taking advantage of the load up and an extended curtailment period. So we kind of threw everything at these units just to see what we would find. So we definitely challenged the units with this, but still we saw great ability to curtail. All the strategies showed a great ability to curtail during the 3 and 4 hour peak windows with small or no energy penalty at all. Here are the best results for the tests for both the cool and the warm weather. And we say best in terms of greatest demand curtailment first. And in many cases, it was complete or nearly complete. And so from there, we'd also look at the least amount of energy at the same time. Summer results are for days with averaging temperature of 80 degrees, and they're under the 47-gallon per day draw. The winter results are for days where the average temperature was less than 65 degrees, and these were under the 69-gallon per day draw. A 2-hour load up and a 3 or 4 hour curtailment was often found to be the best strategy, regardless of the temperature profile. And even under the winter test, the 80-gallon unit and the prototype that would allow for the advanced load up were very good at handling curtailment nearly perfectly every time. Summarizing the lab results, the tests indicate that heat pump water heaters saved 53 to 78% of water heating compared to electric resistance. And I want to point out that the lower range here was from the prototype unit, which did have some issues heating when it wasn't called for. So the units that are out on the market were at the higher end of this energy savings. All the units demonstrated a great ability to curtail demand during a 4-hour evening peak and nearly as well during a 3-hour morning peak. The grid-connected heat pump units reduced peak demand typically between 0.2 and 0.7 kilowatts. The demand reduction depended greatly on the protocol, the tank volume, the control scheme that we sent, the peak period, whether it was the morning or afternoon, and the draw profile that we used. The prototype unit with the advanced load-up capability had the strongest ability to shed the load consistently. And the delivered temperatures for all the production units were nearly always above 115 degrees. And the few lower temperatures that we did find were in periods where we had zeroed out the load up and we had longer curtailment periods beyond 4 hours. Now I'll move on to the field study. Participants received an installed communications adapter with a modular and they connected to their Wi-Fi. During the 2-year project, the participants allowed us to send signals to scale back their water heating during peak times and increase it to load up. Participants always maintain the ability to opt out, however. The majority of the 51 homes had 50-gallon tanks. There were typically 2 to 4 people in the homes. Nearly all of these were installed in unconditioned space, and that was typically the garage. And participants completed 3 short surveys throughout the study so that we could track home characteristics, occupancy changes, water outages, tank faults, and replacements. Field results were segmented into 3 bins: warm, mild, and cool. And here I compare energy use results between the tests under mild versus cold. Mild was between 59 and 77 degrees in orange, and the cool is between 45 and 58 degrees in blue. And the dashed lines are the baseline. During the mild weather tests, on average, there was no increase in the energy use. Not surprisingly, energy use was higher during the colder weather, and also the load shifting test was associated with an increase over the baseline of 11%. Here are demand results for the mild temperature only. During the mild weather, we had a good number of tests, so we were able to compare different strategies. This plot shows 12 different tests that we compare. It includes load up and curtailment demand. Load up is in red with candy cane in the morning, and then the polka dot is in is the afternoon, and the curtailment is all in green. The curtailment results presented are normalized to the hours so that we can compare tests of different curtailment lengths, and the demand changes are shown as deltas from a zero baseline. I have some backup slides that I won't get to here, but they're going to help make these following points that I'll share, which is demand during morning load up, the red candy cane, for the 1 hour tests were consistently about twice that of the 2 hour test, indicating that the second hour of load up was not as important as the first. However, the 2 hour morning load up test tended to produce larger, there's my time, I'll finish up here, larger curtailment period reductions, showing that there was benefit to having that second hour of load up. And the afternoon load up, the red polka dot, has the same trend we saw in the morning with greater average demand and shorter load up lengths. But this trend in the afternoon was less defined as it was in the morning. Also, there were indications that the critical peak strategy was slightly greater at reducing the load than the shed strategy. And so on these cases where you see the arrows, those are cases where the structure is unchanged except between shed and critical peak. And then I go back to the mild and cold comparison, this time looking at demand. And even in colder weather, the demand during curtailment testing was consistently lower than baseline. However, the morning curtailment tended to be greater during warmer weather than cooler weather. And compared to afternoon curtailment was lower for both temperature bands. And generally, afternoon curtailment was similar regardless of weather. I have summaries here for each, but I am out of time, so I will just go to my final slide and say that load control for heat pump water heaters can generate good peak load reduction, greater in the morning than the afternoon, both in warm and cool weather in Florida. Morning reductions were greater than afternoon, and morning reductions were more predictable than afternoon. Multi-hour is preferable to a single hour load up. And we found no energy penalty during the mild weather and the slight energy penalty during the colder days, which is probably an indication of how the load control strategies altered use during the cold days, where we did see an occasional recovery with electric resistance with those heat pump tanks. The CTA 2485B advanced load up capability showed especially good strength in shifting the load. And scaling up for the 3 million Florida homes that are candidates for a straightforward heat pump water heater replacement, that's going to be a single family house, and enrolling them in load shifting programs, we estimate 4.9 gigawatt hour morning peak and 5.4 gigawatt hour evening peak energy reductions potential. And that is it.
Awesome. Thanks a million, Karen.
Thank you.
Super great visuals. Loved all the depth you went into various control strategies. Will you tell folks where they can find your full paper, especially for the lab study? Is it on the FSEC site?
Yes. Yeah, I'll do that. I'll put that in the chat.
Yeah, folks, it's one of my favorite resources out there for load shifting studies. Really great stuff. So definitely encourage you to check that out. Goes through, all the different, number of hours of load up and advanced load up and everything, and then number of, shed hours and all the different configurations. So definitely a good resource there. So a couple of questions. Start with one for Tristan. There was a question about cell costs and who pays for them, because I know you're doing a lot of cellular modules to make sure that connectivity stays high.
Yeah, so obviously customers wouldn't be paying. In commercial buildings, it becomes negligible, right? So historically, we've talked about sort of 10 years of cellular and low-cost cellular over a 10-year plan is obviously real different than a 1-year plan or a 2-year plan, which is how historically the vendors like Verizon have provided. But there's a lot more options out there, and utilities are more interested in, a 5 or a 10-year plan, even though most utilities have said, oh, we're not used to that. All we can do is commit to a 5-year plan. So If you, there's a lot of exciting things in low-cost cellular, even at the residential unitary water heater that make it cost effective, but certainly it's a no-brainer on those larger commercial loads, and please contact us for pricing.
Awesome. Yeah, great call there, because I have seen some prohibitive costs for single family home levels sometimes, where they're trying to charge you essentially full full cost for like a cell service plan for your phone, right? Just to connect your water heater. So I think the takeaway there is, yeah, long-term pricing is a great idea. And then, looking at alternative options, but
It's definitely lower than you think. It's a lot lower than you think, so just contact us. Thanks.
awesome. Great to know. Question for you, Karen. So you were talking about advanced load up going all the way up to 145 degrees. Were you able to prioritize the compressor use for that, or did the electric resistance elements kick in most of the time when you were doing those high temp advanced load ups?
We did not have compressor use during that.
So it was just electric resistance, or?
I'm sorry. I meant to say
electric
electric resistance. We did not have electric resistance for those load ups.
Oh,
I'm
amazing.
pretty sure the
Okay,
advanced
great
load
to
up
know.
doesn't let you have because remember, advanced load up is a grid signal. I'm pretty sure it does it only it'd be interesting if an OEM is on the call, but I'm pretty sure it's supposed to be only compressor. Same thing with the snapback, right? People are trying to say, hey, can the snapback also be only compressor? So that it should be in the spec that an ALU is only compressor.
Yeah, that's what we had.
Great. Okay. Yeah. Super, super good to know. So yeah, I've checked it, taken a look at the definitions and haven't seen that. So I'll have to go back and take a look at the spec again, but that's a great insight. Just for context for folks on the call, a lot of the times when you go up to a higher temperature, at least maintaining a higher set point, be it on a commercial water heater, like the kind of smaller commercial ones Tristan showed off, and some at the PAE building, or residential water heaters, if you have a high set point, sometimes that does trigger more electric resistance use. But if the advanced load specification says that it's compressor only, then that's what it should be. So yeah, great stuff there. Just checking the other questions here.
So Amelie just said that for advanced load up, you can specify the efficiency. So that is a number between 1 and 10. We've been testing it. It's been a little bit mixed, Daniel, when you say that, how many people are actually kind of letting us use that efficiency number, but it's very exciting, right? Utilities want to know, and customers want to know that they're not having the lower efficiency, increased costs of that electric resistance element, or in commercial buildings, the swing tank coming on. So the efficiency number in CTA 2045 is really exciting. And Karen, it was wonderful to see your great results with advanced load up. Super promising. I'm sure everybody loved that.
Yeah, it is exciting.
Absolutely. Yeah, and that's I guess if you want to both speak to that a bit, like how much advanced load deployment have you seen yet? Or is it still pretty low?
Yeah, well, Amelie made that comment, and I know that she's perhaps has more experience than even we do. Daniel, did we do much advanced load up? There was no mixing valve in the NIA end-use load flex, so that was tricky.
Exactly.
Now, what's exciting is some water heaters have come out with mixing valves, but in our fleets, we haven't really had a lot of mixing valve advanced load up yet, right?
Correct. Yeah.
So if Amelie wants to jump in and describe her experience, I think she's the world's expert right now.
I think she is. Yeah, Shannon, do you want to promote her to panelist real quick, and then we'll wrap up? Hi, Amelie. Welcome.
Hi, everyone. Okay, I was not prepared for this.
No, we're putting you on the spot here.
Yes, I guess so. For everyone on the line who doesn't know me, my name is Amélie Besson. I'm a senior program manager, and I manage Pacific Gas and Electric Water Saver Program, which is a daily load shifting program for electric resistance and heat pump water heaters. We've been in operation since March 2022, and we've been doing advanced load up on a number of our participants. including a significant share of water heaters connected via CTA 2045 over the past year and a half, I will say. Previously, we didn't have that capability via CTA. And the results that we are seeing is that Advanced Lab does, like, very similar to the results that Karen shared. Advanced Lab does result in a better curtailment. So we don't see the water heater, turn on during the curtailment period. And also, we don't see as much of a snapback post curtailment, which is really interesting, especially for afternoon sheds where, if you have a grid like the California one, the GHG content on the grid overnight is still pretty high. So we want to avoid that snapback, absolutely. So it's really promising. And then in terms of sharing more results, I just submitted abstracts for HPWH server study next year. So I'm hoping that they'll be, successful, and we will share a lot more results at that time.
Amazing. Thank you so much. And yeah, definitely looking forward to checking that out. Well, folks, we are actually having to end a few minutes early here because HPWHI has another webinar coming right up on heat pump water heaters in commercial kitchens. It's going to be a back-to-back session. Definitely check that out if you have time in the next couple hours. But otherwise, thank you so much for coming. Thanks again to Karen and Tristan and Daniel for presenting. Thanks for hopping on, Amelie. Yeah, appreciate your time and have a great rest of the week. Hope to see you on Thursday for official heat pump water heater day. Cheers, folks.
Thanks, Karen and Amelie. That was
Bye.
great.
Thank
Thank
you.
Bye.